Okay, audio check. 1, 2, 3. Sounds like we're good. So, ladies and gentlemen, welcome to the Discourager of Hesitancy. We are making a game with no game engine and no minimal dependencies, I should say. So, we are in kind of the tail end of things. I have any number of things we can add optionally while we wait for final pieces to show up, but overall, it is ready. We're waiting on a couple of things. I need to refreshen up my Emacs here. It's all for compiler stuff last week. Monday, Thursday is game day. Friday is compiler day. So I gotta go reset my system for that. Just a moment while I kill my Emacs here. Actually, let me just save out a number here. What did I do? None of that's important, so we can commit dash amend no edit. Okay. Just store this number real quick. Metrics in my metrics file. Metrics input weekly. We've only been doing this compiler for 15 days. That's not bad. I know it seems longer, calendar-wise. And let's see, last Friday was the 9th. It means we did not record a week in there somewhere. Oops. We may have failed to record 2 weeks. Just from my own processing. Yeah, that might be 2 weeks missing. October 18th, 25th, 9th. Oof. All right, we're going to have to go dig those back up eventually, but we don't need to do that right now. $14, $15, $16. We're probably on week 17. But still, not bad, not bad. So this will probably be 1025, 1102. Those sorts of numbers track. Okay. So write myself a to-do item. Gig up old hashes and stream times for weeks 15 and 16. We can take the information here and compile basically some different code performance metrics to see how we're doing. So that's all good. Add everything. There we go. Okay. Now we're going to close out Emacs and reload Emacs so that we can start fresh this week in our game dev. Size it down and load up our project. Sleuth, documentation, to-do list. And a journal. Okay. right, so we need better art, we need better music. Those are all in the queue. We do have 2 bugs. I really don't feel like, only sometimes. We'll have to come back to that. Replay won't reset or navigate by word once you lose. Okay. I don't feel like dealing with those right now. Once we get some better audio in, we'll have a play button settings scene. So yeah, things are in pretty good shape code-wise. Let's see here. Zaka 6. I spent 1 to 2 days experimenting with my Lexer. Nice. Wrote the whole state machine based one, which was supposed to be faster, but it's 2 times worse than the regular one. Probably due to speculative execution not working as well. Interesting. No, that's why I always tell people, like, when you want to optimize something, there's all of this tribal knowledge, this intuition about performance and how it's going to behave. It almost never behaves that way. It's you got to measure. So 2 times worse than the regular one. Interesting. Now, to be fair, also, if you measure the time that your compiler spends in the Lexer, I would be shocked if it was anywhere near as high as like 10% of your total execution time of a compile run. Parser is going to probably tend to be a heavier lift. Semantic analysis is almost all of it. That's well, an optimization. Obviously, optimization is going to be terrible, but interesting. So your state machine based one was less efficient. Crazy. I mean, and I wonder, yeah, without seeing any implementation, I can't have any idea why it would be 2 times slower. I just saw an article about state machine Lexer and tried it for research. Yeah, no, that is cool. So, but now you measure it and you know. You have ideas for making the state machine based one faster? It doesn't do any SIMD or loading more than 1 byte at a time. Oh, okay. If it's loading the file data 1 byte at a time, that's terrible. If you can slurp that in as a single file and then walk the character string, I can link you how this assembly looks if you can read it. My assembly's a little bit weak, but you can link it, sure. We can take a look. I don't do enough of it. Remember which registers are used for what kinds of things. Okay. X or L. Only a Q. Yeah, I'm too rusty. This is not coming automatically to me. LEA is, oops, what? Load effective address. Okay. Basically 2 loops with state table transition access. Okay. Couple of XORs to 0. Yep, that makes sense. Compare equal jump. Compare move jump not equal. Return Q. Okay. Cool. And it exits when state is terminal. Nice. So that state machine is slower than what you were doing before. What you were doing before, was it using SIMD? So again, if it's your file access is 1 byte at a time, you should really slurp the whole file at once and then just walk the single buffer. Okay, so your one's not SIMD either, so you are comparing apple to apple. Entire file load is loaded. Yeah, that's good. I told a story one day, a project that I was on that was loading 3D assets and texture data 1 byte at a time off the disk. That was a painful project in some ways. Cool. Speculative execution not working as well. Yeah, you're gonna, if it has to keep flushing the instruction pipeline, that can get pretty spendy. So let's see here. Where was I? One thing we did. Okay, so Steam integration. I actually started that this weekend. Get game uploaded to Steam and test running in Steam. Automate uploading a clean build to Steam. So this one is done. This one's not. Determine list of Steam features to integrate. DRM leaderboard. What's it called? Achievements. I can't spell. Username for high scores. Upload, download, config, and replays. Config, high scores, and replays. So those are the list of things I'm currently considering. Yeah, so Monday through Thursday is game development day with no game engine, 4 dependencies. Okay, so we did this one. I've got a good start on this one, so that's one of the reasons I was saying we might start with a teeny bit of that today's list. So let's get things warmed up here. Week 22. Release French for a second. Oops. Release size. And then today, what we're working on, the 18th. So that probably means that was not the 10th. Did I just copy paste a week worth of dates? 19, 20, 4, 5, 6, 7. 7. Why did we? Ooh, good heavens. Apparently I didn't record things very well. Your title is not updated. Ah, no, you're fine. I don't mind going off topic, but I did. I typed it in and then didn't click submit. That should help change the title. Whoops. No, I'm interested by other people's projects and lectures and whatnot, so help yourself. I don't mind going off topic at all. At least not at this stage. I don't have enough viewers in chat to be like truly distracting. I can usually get a few good hours of work in with, a couple of good sidetracks in. If you get to where you have hundreds or thousands of regular viewers on the chat, it's like, you know what? You have to change the rules. Do you have a released game or making one? Making one. So here, let me give you the short spiel. Let's get a shell up. So we're building a game with minimal dependencies and no game engine. So every line of code, let's see, let's find a source, word count, lines, every line worth of takes a little while. It's probably counting up the sound warehouse right now. Every line was generated by me. So here's 11, 12 million lines of code. To be fair, we're embedding audio data and we're embedding image data, which is where most of those lines come from. If you actually work it out, it's about 20,000, 25,000 lines of code right now that are meaningful. And everything is statically linked. So if I build dependencies, builds release version. Let's look at the release version. Well, let's look at the Steam version. My entire executable is, 300, 400 megabytes because of the audio data. Nowadays, I have to include the Steam DLL because it will not statically link. But right now, everything else is completely statically linked, standalone executable, except for the Steam piece. And if we run that, because we wanted to test it anyways, it's a simple game because we're building from scratch. Start simple, then you build a better game in the second one. How did you embed it? Oh, we're getting to that. If you're interested, I'm happy to address that. Oh, it's going to restart it from Steam. So let me add my company account here last. Game Studio. Let's just see if it works. Do I remember the password? Oh no! Hold on, I have to authenticate using a mobile app. Just a minute. Let me go grab that. I try to keep the phone out. Embedding. Yes, we'll talk about embedding in just a second. Let me go get the authentication thing. Mobile authenticator. Be back soon. In case somebody comes by and sees an empty chair stream. Just a moment. Okay. Oh no. No. Try again later. What? Oh, just a minute. Enter a code. There we go. Okay, so my Steam is loading up. I'm not sharing the Steam window. You don't get that lovely joy. But there's the game. It loaded up out of Steam. That's so cool. Oh, wait. What? That's a little bizarre. Now I'm confused. But anyway. So it's a simple word logic game, deduction. Let's go sprint mode. The art's not final. This is all crappy programmer art. No duplicate letters allowed. Then you have to deduce what the word is. So very simple game in some ways, just so we can build up all this technology that we're going to use in the next game. Seems like only C23 has an embed directive, and C++ you're forced to have it in a string literal probably. That is correct. We are using C++. Oh, I guess you can't see the shell. Oh, and it didn't actually launch from here. Frames per second, 1,000. I wanted that data anyways. Yeah, so we embedded it all in string literal. So I wrote some scripts that transform the data the way I want it. So in here, yeah, that's more like it. Frames per second, 19, 2000. And then you just deduce what the word is from the clues H and O. Not that helpful, D-O. D or O can contain at most one, so T and A are out. O and D can't both be in, so U must be in. Oh, we get our CH, so no D, therefore O. B logs. What's F or G? Is our last letter. And of course, I can't think off the top of my head what that probably is. But anyways, so like I said, simple game, keeping the scope small. We're doing more of a Blizzard and less of an Amazon. Blizzard started off with some small games before it made it big with Warcraft and World of Warcraft and StarCraft. Amazon tried right off the bat to build a big blockbuster, and well, you know, who's talking about Amazon games these days? Let's cough. I should have seen that. Anyway, so that's the game, and if we run it out of our debug, which has not got all the Steam code built in there. What? Yeah, so if you want to look at like the font warehouse, it looks something like this. Yeah, lots of string literals. We're going to go through a compression phase here towards the end of all things, but it's just string literals all the way down. Sizes and string literals. Anyway, so like I said, simple game, playing around, building, learning. I want to get this released this year before Christmas sometime. Then we'll have like a dead space between major projects where we do some more exploratory short-term projects. Then eventually get back into a new project. Although I'm not sure how the old streaming schedule is going to keep going. Might have to change a little bit, but I'm going to take things one day at a time right now. So yeah, embed it that way. And we don't do it by hand at all. We have tools for embedding, you know, if you want to embed the fonts. It's all fairly abstracted, but here's where to write it. Here's the name of the class. Here's the pound define. We write out size mode in bytes. That's a long story. Then we write it out with the lambda function. Everything goes into the read file, dumps it all out, and out it goes. Which is maybe not the best example. Maybe well, probably not the shader either. Embed probably sound waves. So yeah, we parse the audio file itself. Where is it? So this is reading chunks out of the WAV standard. Then depending on what chunk it is, here's the format chunk. Here's the data chunk. I don't remember if we... Oh, here's the read sounds file. So it uses those two above functions to read the chunks. Then we write out our header file. Then we write out the binary data. So there you go. Embedding done by hand automatically. So let me see here. I need to, at any rate, oh, do I want to do that? Okay. Let's do a game scene code up. We're going to do a clean and debug build. Let me check my make file. Yeah, so we should not be doing anything Steam related if I rebuild this right now. This will take a few minutes to build because of that sound file. The old GCC is a little bit slow parsing a million line string data. But we will get all that shrunk down. So yeah, if you have any questions about anything we're doing or why we're doing it that way, basically I look at something like, you know, Unreal or Unity, and even an empty scene with nothing in it, the game package is, you know, a couple hundred megabytes at the minimum. If you took away all of my audio data and stuff, this would be maybe 25 megabytes. I used to know more accurately what the executable itself was, but so I'm just trying to build a small enough set of technology to build what I want when I want to, without all the bloat and all the includes and dependencies and libraries having to be drugged around. I don't like the dynamic linking. I just want an executable. So that's what we're working towards. Simple game for the first one. The second one, since we've built out an awful lot of technology, the second one will be easier to build. However, there are a lot of improvements. I'm not saying my current game technologies I've built are perfect. This is all the stuff we would like to get around to. But, you know, it takes a while. I want to run the debug mode one, so you can see my exact list of dependencies. Although, let's see here, we can look it up in about scene. I think I've got them listed in there. There you go. There's my list of dependencies. I use GLEW, which of course brings in the GLFW, which is how I support the OpenGL 3.3. No extensions, bare OpenGL 3.3. So that's kind of one dependency in my mind. I know it's not technically one dependency, but when you install the one, you get all the three. So, and then GLMath, free type for font loading, and then port audio. And I really want to get rid of these two. They seem like really heavy lifts for what I'm using them for. So they definitely contribute to the bloat that I currently have. Streamline those down. For what I use the math libraries for, I could probably write my own. Orthogonal camera projections are not rocket science. And then, yeah, that's unnecessary complication. The free type library, there's a single file one somewhere I know about, or a header only. It might be a lot simpler for me to link into. Get rid of a lot of the dependencies that free type drags in, which I don't like. Or, and I do have the idea that I might want to write my own font renderer, but that's a lot of work, so. So we'll see about these two. I'm perfectly happy with port audio. It's a single header file and a static link library. pretty simple to get it wired in and working. Yeah, this sound warehouse takes a while. We are going to compress all that data, but I would like to know how much compression I'm getting, so I'm waiting for final assets before I measure that. It'll shrink our lines of code by a ton, and just the amount of bytes that the executable takes up. So like, I'm pretty sure most of my sounds are stereo, although the data on both channels is identical. So your left and right speaker data interleave, and if you just copy the same data over and over again, well, what's the point? If you're pumping the same audio out of left and right, you might as well just make it mono. So that would cut us in half. We're running our embedded data at 16-bit PCM, pulse code modulation. And we can probably shrink that down to 8-bit mu-law encoded audio. So it cuts in half again. So if I quarter the size of my sounds, and you'll see when we run the debugger, it'll tell me how much physical space my sounds are taking. So if we cut that in a quarter using the two simplest compression methods available to me, that's pretty good. We have other ideas for compression. I do have an idea for one that would use FFT, fast Fourier transform, twice. But I don't know how fast the compression and decompression would be. And at the very least, decompression would have to be very fast. Plus, FFT is just a fascinating algorithm all on its own. Like the FT, the Fourier transform, is like, oh, okay, it does some math things. It transforms from this to this, but the fast Fourier transform is where they figured out how to make it run screaming fast. They basically turned it from an n-squared algorithm into an n log n algorithm, but the way they did it was very clever. And it actually turns out to be very little code. Like it's very compact. Oh, what? Oh, I know. Main Steam interface. Okay, so one thing we should do, actually, so basically we stub it out if we're not building in Steam release mode, is not include that. Oh, namespace is like my things. Me and my pedantic pattern. Okay. Anyways, we now have a debug build, so we should be able to run it. And there we go. So like my audio right now is taking up 271 megabytes of uncompressed audio, 16-bit PCM, 2 channels. On average, my sound files are 7 megabytes. Font data is trivial, shader data is trivial. The images are 46, 47 megabytes. That's going to grow a little bit. But again, I'm not compressing this. This is raw image data. I'm going to replace the raw image data with a QOI compression, I think. It should get me down half or maybe quarter of this, somewhere in that region, depending on the image. So if we cut that in quarter and that in half, that's pretty good. So what's that? Almost 300, 150, 75, 75 plus 25. So we might be down around 100 megabytes data by the time we're done. 100 megabyte executable. That could be pretty good. I do have a bunch of music that's not playing right now. It's not royalty music, but I was only using it to prototype out the music playing system. So the audio is embedded in here and we can play it, but I've turned it off because it's not the final music. I got the system to work and then turned it off. Then, like I said, list of dependencies is very, very simple. This is not a release build. This is a debug build. Interesting. Oh. Yeah. Why does it say it's a release build? Anyway, so there you go. That's kind of the high-level overview. If you have any questions, let me know. Otherwise, we're going to get back into cleanup from last week when I was apparently too lazy to look up the correct date. Sheesh. What's up with that? Who does that? So last week was 11/12, so 11, 12, 13, 14, 15. Today we pick up at the 18th. Yeah, so that's correct. Okay, good heavens. So we saw frames per second on the Steam build of 2,000-ish frames per second. The size was, we saw this on the thing. Size was, there we are, right there. Just so I can show a chart, like when we added art and when we added music, it'll be very clear. And then when we compress, that'll be very clear as well. And just so I can keep track of, if I add a dependency, how much room does it actually add? We can go look at a chart of all this later, like at the end of the project. And you'll also see where the performance hits came. Oh, on week this, the frames per second dropped a ton. So far it hasn't. Like we've kept everything well above 2,000-ish for the most part. Okay, so today, to-do list, I want to automate. Oops. So we're going to copy this line out, put it in here. So right now I can manually run the build to Steam and upload it all. But that's not what we want to do. We're going to add version number to splash screen to the main menu. That way we can see when we get it uploaded to Steam that it updates and plays correctly out of Steam. What else do we want to do? We want to do more doodad stuff. So fix and finish the Chalkball doodad. So let me show you what's going on with that. So the game is playable, it's functional. But we're trying to add fun little tidbits to make it more interactable. There's an airplane that launches pretty early, and then every, I forget, 1 to 5 minutes, it launches again, left and right, different heights. We have this chalk doodad where you can, and it's not working right now. You click and drag it, and it should behave differently. So we're gonna fix that. Whoop. So that chalk ball is broken. Then maybe after the chalk ball, we'll do like little chalk bubbles. So it'll be a thinner line and like have a little shine on the top instead of a shadow on the bottom corner. And they'll just kind of float around behind all of this stuff. Maybe right click to pop it. This one's right click to drag in and toss it. Just little non-game related things to interact with while you're sitting there thinking. I always liked that about Hearthstone. Their environments were very interactive. So that's kind of what we're aiming for here. Okay. Dragging, physics, animate, in, out, let's see. Those are like the 3. better dragging, fix the physics, then animate it in and out of the scene. Okay, so let's go add our version number to our main menu. Version number right now is stored in the global namespace. No debug is release build, else that release build is 0. So we're logging things out. What is that during application startup? Application release build. Blah, blah, blah. When we write out our config or read it in, where's release being set? Is it set from global? Where's this number coming from? Read value, release. Oh, because the last time I ran, it was in release mode. So it should pop up as developer mode if I reboot it again, right? Now it says developer build. Okay. Because that's what we loaded from our config. Okay, that makes sense. That has nothing to do with the rest of it. Okay. So we want to add our main menu a version label. Oh, let's see here. Where do we want to put it? Oh, we still need this. I think we do. Forgot this flag. Yeah, we do have to check because we break out early. Yeah, okay. So we do need that. So chalkboard text. Let's just add another text, right? Underscore label version. Let's put it up by game name. That's a little bit more sense. That text 0.0 d. Let's see, minus d, modulus d, modulus d, modulus d, modulus s. Release build question mark release. Otherwise dev or debug. Oops, not that. Global major. Minor and patch. text color, alignment, all that's fine. Okay, I gotta put it somewhere. I'm thinking down at the bottom center. Small label font size. Scale something. I don't know, 24 pencils should be big enough for anybody, right? Oops. Underscore label version. Font size, but not the rectangle. The rectangle that'll hold our thing. We basically want so rectangle. We're going to be at x0. Our y will be the frame height minus 100 and I don't know, 40. We can patch this up later, one way or another. The width will be the full width, frame width, and the height will be, I don't know, 40. Okay, then what? Address of m_label version. All right, we render. We initialize our appearance. Oh, this is not 32. Oh, yeah, that's fine. Oh. No, it's not. That color is wrong. 192. 192. Maybe we make that even duller. 148. 48. Okay. Set our rectangle, set our rectangle. Set our text size. Add it to our fading function. Okay. Okay. Hey, Dravest. I'm doing good today. Doing good. How are you doing? We're adding a small version number to the main menu. And then we will do a small piece of Steam integration automation, which is what? Oh, finally happened. Okay. Let me clean up a few files and then rebuild. We'll do a little bit of Steam integration work. It's up, it's running, it's just not automatic. Like, it's a very manual process for me the first time through. So I'm writing a Python script. And what I'm going to do is I'm going to stop sharing Emacs for a minute. I'm going to delete my password out of there. And then I'll show the script again. We'll finish that little Python script up to do the upload. It's actually kind of an interesting little process. Oh, I may have to delete more stuff than I really would prefer. Oh, well. We'll figure it out. Oh, well, Anyways, basically, we need to be able to upload to Steam with a single command, as basically as part of the Steam build from our make file. If you go to my make file, I now have a debug build, a release build, and a Steam build. And the Steam build does a little bit extra. It copies the file over, it does the build, and then it's going to run this Python script that we're writing. So this is done. Okay. Okay, so the debug version shows up. We just want it over to the side. Easy enough. We'll move it over to the right. That rectangle. I'm just going to move it in 100 pixels. The height is fine. Width minus scale 200. I'll just shift it over to that bottom corner. I'm doing very good as well. Installed a second monitor this weekend. Nice. Yeah, you can never have enough screen real estate. That's not quite true. My current setup right now is one big monitor, and I wish I had two slightly smaller monitors. I think two monitors is better than one, even if it's huge. It did not move. Why did it not move? Did I not build? What I built? Yeah, screen real estate is huge. Every time I work at a place, you're like, oh, well, you need to be on the move. You need to be able to go from meeting to meeting. So here's a little teeny laptop. It's like, oh my gosh. I need bigger than a 13-inch screen. Thank you. I don't move around that much. I would much rather have a big machine. What? Why is my debug not moving? All right, we'll take a quick restroom break. No. Quick restroom break, and we'll move that around just a little bit. Be right back. Okay, we're back. Yeah, for most work, I think 2 or 3 monitors actually is usually a sweet spot. Yeah, I found with 3. Actually, no, you're right. You're right. I've done 3 once, and I was not sad. basically what it let me do was work, documentation, and then whatever on the side for either like my personal emails and stuff, or like my music player, or something playing in the background over there. So having three was not bad. That's true. That's true. Yeah, two or three is good. All right, so oh, well, I know what this is then, because we still have it centered. Set alignment, vertical alignment center, fine. You want this off to the left. You could put this off to the right. Right's fine, right? That's our main problem. If you narrow it on both sides and then you're still centering it, it doesn't move much. The airplane doodad. Oh, I should write that down in my to-do list for the day. Airplane doodad doesn't scale with Screenwell. There's something we're not scaling there. It's not going to be hard to find. Okay. There we go. Debug 0.01. Great. Good enough. So now that that's there, maybe we change the name real quick. Developer build. Okay. As far as the journal is concerned, yeah. Okay. Easy fix up add cache. Oh. Oh, let's see here. My journal to do add everything. Unstage, no, restore staged tools, upload to stream. There we go. Added version number 2, main menu. Sounds easy. We're actually going to open upload to stream, but that has some personal identification information in there, so we're going to stop sharing Emacs briefly, for which I greatly apologize, I'm sure. Is this? Nope. Trying to find the best way to do it. We're just going to do that for now. Okay, tools, upload to Steam. Okay, now I need to hide some of this information. What do I need to hide? Probably these three things only. So I'm going to temp butler. Oh no, it's locked by myself. Oh, bother. Did I do anything interesting? I don't think so. So I'm going to steal the file log back. Is it steal? One. 10 1111. Okay, now I can share Emacs back again. I don't think there's any terrible incriminating information here, other than you can see some of my file path stuff. Doesn't matter. But yeah, Steam is interesting. They give you a little command line tool, Steam command, and then you just run this command, and it uploads everything for you. And you have to do a little bit of work to get these files dumped out, so that's what this code is for. Oh. Now let's see everything on the console, thank you. We did output app build file, which is this thing. Output the depot. So your app is just all of your stuff, right? The depot is, we're taking all that stuff, we're basically putting into teeny tiny chunks of zip files. Then when you patch, they figure out which chunks in the depot have to be patched. So that's why the patches are reasonably quick. As long as you don't reorder things and make, huge changes, it can pretty quickly figure out what needs to be downloaded and make it as small download as possible. So that's kind of cool. So we need to know what the depot build number is. We're just going to keep uploading the same one. I'm going to put those out somewhere. Let's just do note. Building. And we'll know when it's a success or a failure. Good enough? Good enough. Should we try to run it? Chmod plus x this file. Did I put in a proper? I did not. Let's see here. I can steal one out of. Actually, layout math has a proper line. There we go. Upload to Steam. This one should fail. Oh, interesting. Set log file. So let's see. What's in my logger? I think there's a way to set it. Set log file. Oh. That should fix that. No such file or directory, which is scripts path. SDK, tools, content builder, scripts. Write that. Oh. Write as text. There we go. That's how we're testing it here, not through our full process. Depot build script is not defined. Spelling error. Got it. Give me a second there. Utilities has no attribute checksecute. What? Oh, same deal. Utilities. Upload to Steam 78. Okay. All we have to do is go to the right directory. Utilities dot push director. Oh, enter. What's it called? Enter directory, push directory, enter directory. And what we want to be is in the SDK path somewhere. And I need to find out what that folder is called. Let's go in there. Let's go to. All right, let me shortcut myself this one. Steamworks SDK, tools, content builder. So we want this. Okay, so there we go. I would expect fail to come up. Oh, it's trying to build it. Wow. And it should fail because I don't have that app and I don't have that depot. Those are fake numbers. Big file. We're in the source directory, so we need to go up to tools and then upload to steam.py. That's basically it for the make file. We should just have that all be nicely automated soon. Now, I can have those be variables inside of my make file and pass them down or hard code it into that script. Either way, not too worried about it. This is probably failing on timeout due to password, if I were to guess. Oops, typo there. Yeah, it's just stuck here, which is fine. I kind of anticipated that not working because I didn't put my real password in. There we go. That should help a little bit. I don't want you to see all of my app data numbers. Just remove all that. Anything else? I think everything else is good. So what I'm going to do now is I'm going to replace this information. So let me hide Emacs briefly again. put in my real information. Save. I'm going to quit that. I think now I can share Emacs again without giving away any information. Compile Steam. Steam automatically does a full clean because it assumes we've been building in debug or release mode. So this will take a while to build again. That sound warehouse is large. We shall see what happens. This will take a few minutes. And just think, the next game we build, all of this will basically be done. I'll know how to do everything. It'll be plumbed. I'll have snippets of code to copy paste to make things work. Everything will be so streamlined next game. One more simple game, I think. Maybe like a little 2D spaceship shooter from like the 80s. Slightly jazzed up, but not too much. This is also an homage to a 1990s game, early 1990s game that I played on the computer back in the day at school. Then we just add a few bells and whistles of our own. Like the notebooks, you can store 4 different sets of deduction notes. That's been very handy. The original was not very animated. Ours has a lot more animations and sounds and things. My art is not right now better, but it will be. I've got my best man on the case. Yeah, not bad. If this little script works the way I hope it does, where is my Steam? Pop up here. Would like to know why all these games are in here. And I'm logged in thusly. It's fine. It's fine. As long as I can get the update. Manage. I can set custom artwork. Oh, never mind. That's the client. I don't care about that. There's so many good games I need to play. I think that'll be another thing we do a little bit more of between major projects. We'll do like a mini lecture, a little toy programming, and maybe a little bit more actual gaming on stream. I really still want to play some Hollow Knight. I want to play some Noita. No Man's Sky just had a new update that I kind of want to take for a test drive. Nova Drift finally released. I've not beat Ori and the Will of the Wisps yet. That's sad. So many games, little time. Wizard with a Gun. I still want to play that one. Man, who has time for all that stuff? Yeah, this build can take a while. We really do need to get onto that optimizations phase. But yeah, Steam actually has features for doing a lot of the things I was like, it would be nice to have, but I don't want to code it myself. If they already have code for like leaderboards, that's perfect. If they have code already for uploading and downloading your settings from a computer to computer, that's perfect. What else was there? I don't remember now. I wrote the list out this just shortly, not too long ago. DRM. So I'm not a huge fan of DRM, but if I'm selling something through Steam, you might as well use their DRM so somebody doesn't download the Steam game and just copy the executable out. Doesn't seem very nice. Leaderboard achievements. I don't really know that I care about achievements. So yeah. Ooh, hey, it's building. Good. All right. Now it says it's building. And it can take a few minutes. See, this is the old stuff. Where's my new stuff? Why is that not being logged? Ah. Well, shoot. Doesn't look like we're getting lucky. Scripts. I'm going to get rid of those two. Oh, this one. Doesn't look valid at all. $126. All right. Well, we may have to go do some more debugging on that script. Maybe what I'll do is I'll do editing in Notepad++ so you can't see it, and then we just run it from the command line. Literally, there's not that much going on. You've seen the script without the numbers. We'll put the numbers in. All right, so we're just gonna kill it. This file is being helpful. Okay, so let me pull that up in something else that's not being recorded. All right, open file. Oh, sorry, this is not the most interesting coding since you can't actually see the code, but you know. Tools. Upload to Steam. Delete build log. Oh, no, I don't want that one. I want this one. Okay. I'm giving everything as an absolute directory. So that should not be a problem. I've renamed those files, so I should see those just fine. Got my script here. Where am I at? CD. So when we run our make file, we're in here. Is that true? Yeah, we don't change directory here. So what we want to do is dot slash. Well, let's just copy the command. Okay, building. Now, over here, I do see those files were created freshly 129. So that's perfect. Let me check the files themselves. That looks okay. Post, the depots. That all looks correct. Then the depot build file. Local recursive depot. Yeah. So those two files are being outputted and look correct to me. So that's good. Then tools, upload to Steam. Oh, that's where our log file's going. Oops. Now you see a little bit of information you should. Oh, so that could be why it's failing. I should not do that. Let's see here. CD up tools. We run it, then we CD back into where we came from. Just make sure. That means that the log file will go where I want it to. So let's go fix that log file real quick. Word sleuth source. Delete our log file. Okay. Now, what we're not doing correctly oh, what's this that we're cited for? Okay, well, I definitely made a few mistakes there. Python strings. Okay. This is where I left off on quit working the other day and did not come back to check and run some easy fixes mostly. All right. Now if we run this, we want to simulate that run from make file. Okay, SDK path. So where does that come from? SDK path. Command template. Command template doesn't need that. So our arguments needs SDK path. Run it again. Now, I have a log file, and that does look like it actually contains the stuff. We have 133, a new app build and depot build file. Both those look better. So it may actually be running now. Reload. Like I said, this may take a minute. Oh, the other thing. I knew I forgot something. I remember reading this, and then we didn't do it. So we're going to kill this. That command needs plus quit at the end. So the Steam command, you can chain commands together with a plus sign, right? So it's plus command arguments, plus command arguments. We need to do three things when we use Steam command. We need to log in, we need to run the app build, and then we need to quit. If we don't quit, it's left in interactive mode, which is just going to hang forever. So let's try that again. There we go. Okay, computer's not been authenticated for this account using the thing. But the whole build process now is very nearly in. But it's because I'm logged into the other account on this computer. So all I need to do is get that authenticated. Hey, JTL, doing good today, doing good. We're just doing a little bit of automation around uploading our latest build to Steam so that it's a single command for me and making sure that it actually works. So unfortunately, I have to authenticate everything every time I touch Steam. But I do have everything we need. It won't let me log in because I have to punch in the number from the thing. So let's do this from the command line. So you can't see what my passwords are. Tools, content builder. Now I should be able to run this command. Oops, not that one. Steam command login. What? Oh, CD builder. There we go. Checking, etc., etc. Log in. Oh yeah. Let me go get the Steam Guard code. Hold on. Okay. Okay. User info should be good. So in theory, this will work? Question mark. Oh, come on. So in that shell, oh. Interesting. When I run this script, do I have to prompt for input? Because if that's the case, I can't do it from a single command in command line. If I have to prompt for the Steam Guard thing every time I run this script, that's not going to work for me. Not from make. Now I can still run the make command and then run this command separately, and it can prompt me. Is that true? How is this computer not been authenticated? All right, let me go get the thing again. Okay. Do that. Of course, I approve. Okay. So that authenticates that. That should be fine. Now if I quit and run it again, it wants the current code again? Why? Every single time? This seems excessive. This is unfortunate. When their authentication makes it impossible for me to log in the way I want. Doing that as a sort of add-in to Emacs. Okay, so here's what I do. Emacs has a command called compile, which in the directory you're in, it looks for a, well, it just runs make, which is a program written way back in the day, old school, and it'll make, looks in the current directory for a make file, and this make file is how I build stuff, right? So here's a list of the object files I have to compile. Here's a list of all the libraries to link, etc., etc. And when I actually go to do the build, I set up the directories the way I want, and then I run make on itself. Anyway, whatever, it doesn't matter. This part, make, build. So that makes sure the directory exists, and then it runs the compiler, which has a variable up above with the current flags, with the linker flags, with the libraries to link, etc., and it keeps track of all sorts of things. So I'm trying to add this one line of script to the Steam build. So right now it builds things with a special set of flags, the Steam flags, into the Steam directory. And then I want it to go into here and run this script. But this script has to authenticate to Steam, and the only way to do that is with a mobile authentication app, which I have on my wife's phone because I don't have one. And while that's inconvenient, the fact that this script won't run unless I type in the number every time is a pain. So, now, okay. I'm pretty sure there's a way I can run it without having to do all that, but I'm going to have to go look at the documentation. So just give me a minute while I log into that. This is me learning. I have to use this stupid thing again. I hate authentication methods. Prove. Show me the thing. Oh, I guess it's fine. Documentation. Getting started, Steamworks SDK, maybe getting started. Uploading to Steam. Blah, blah, blah. I want to see the Steam command. Logs itself in. There used to be a multi... simple build script. I've read most of these, but it's been too long. Edit app metadata and publish app changes to Steam permissions granted. Install setup, the app, set up SDK. I made the config files. Depot scripts. Oh, okay. To set up Steam command for continuous integration, or just on a machine or video that will get re-imaged frequently, you'll need to include the config file that contains your login token. Oh. Steam command login username. Enter your password and the token. Type info. Quit. Steam config VDF. As this file may be updated after a successful login. Oh. Okay, so maybe this isn't that bad. All right, sorry folks, we're learning how Steam works here. Reverse engineering it. Not reverse engineering, but like they made choices about how to implement things, and I now have to find the one line in their documentation that tells me what I need to know next. So I'm going to open this magical mystical file somewhere else. Where is it? Is it this folder I want to look at? SDK, tools, content builder. There's no config. Where's this config? Steam. What? I don't. What folder is that? Is it under users? Is it part of my roaming profile now? So let's find my app data roaming. Nope. Maybe it's part of my local. Steam. Local VDF. Or is it in my install directory for Steam? This is where they're not clear. Sometimes C, program files, Steam, config, this file. Okay. Auto update, IPv6, app. We did manifests, blah, blah, blah. Authentication, remember machine ID. Okay. Oh, so it has 2 accounts associated with it. That's fine. Generally. So if I log in, which I thought I did, log in, username, oh, and it just worked. So does that then mean this command will work now? So let me quit. It uses the last cached credentials, so now this might work. So once per day, I have to do this unless I don't ever switch accounts. Computer's not been authenticated for account. Blah. Oh. This computer has been authenticated, thank you. God got it. Blah, blah, blah. Don't share authenticator with anyone. Don't type them in a website that isn't run by Valve. Confirming your sign in to the Steam client or website. Okay, so what if I exit Steam and I log in with the authenticator app? Where does my authenticator app? That says sure, whatever. Okay. Tap. And now my internet is just powered off. Unbelievable. Somebody pulled the plug on my internet. Good gravy. Why did my children do this? In the middle of authentication, too. Gotta wait for the internet to come back. We'll just keep recording, but oh, for Pete's sake. Router reboots. Never fun. Ugh. All right, well, I gotta go figure out who keeps turning off the power. Just a minute. Okay, should be coming back up again soon. Very soon. Not as soon as I'd like, of course. So let's reboot my camera. Okay, camera's back online. Internet back online. Okay, I'm gonna stop streaming and then restart it. Oh wait, is it back up? I think we're back live. Audio check, 1, 2, 3. Okay, so I don't have to shut down Steam when I lose my internet, or OBS. It does reconnect automatically. So that's good news. Now, where was I? What was I doing? we're trying to authenticate with the mobile app. Oh, what? Here we go. Click. Sign into Steam. Steam should be logging in now. I hate modern authentication protocols. Steam is not signing in. Come on, Steam. In. Request. Approved. Okay, there it goes. Now it's logged in. Okay. If we go over to my command line, we run that. Cached credentials not found. Okay, that's good, right? Proceeding with login, using SteamGuard, two-factor code. I approve. Show me the code. It's not gonna let me. Oh, come on. Rate limit exceeded. They're gonna not let me. Are you kidding me? Rate limit exceeded. Come on. What's the rate limit and how can I get it back? Wait a couple of hours. Okay, so we're done with this line of inquiry. Because now I can't log into Steam via the command line for a while. Jeez, McCracken. I don't know if I've mentioned this, but I hate modern authentication protocols. Alright, so that's going to go get hidden. I guess my tools go away. I guess we're just blocked on any progress on that front at all. For a while. Sheesh. What fun. Editing version number 2, main menu. Started automation of Steam build and upload. No love. Authentication issues. Using crashed credentials from my other account. We're interfering with the Last Penny Game Studio login. Then the internet rebooted. And now I'm rate limited on attempts. I'm gonna try again later. So that sucks. Okay, Aiplane doodad. Let's see if we can just look at it and figure out what's wrong with it. There's a number somewhere that we're not caching correctly, or not scaling correctly. We have to scale everything to the screen. I'm going to launch it more often. As long as we're scaling with respect to frame heights, we're fine, right? Duration's fine. Rectangle width was already scaled above. Radius is radius scaled. It is scaled, so maybe it's fine. We're just gonna watch a whole bunch of launches at different screen sizes. Now we have to go back to debug build. We're not doing Steam builds right now. Which takes time, which I don't want to waste, but here we are. That's why I was trying to finish up that Steam stuff. You log in once, you're done. Nope. Instead we have to rebuild. Too bad. Okay. What that probably means, oh, I closed it already while this is building. I did. Is I can modify that script. To not save my account password. Just my account name. But we can't test that for now because we're rate limited. Okay. Well, not as productive an early start of the day as I'd like. I It's already running behind where I wanted to be. I had to go run some other errands this morning. It kind of killed my whole morning. Not just errands, I just tasks, a bunch of random tasks. Didn't touch a single one. I probably won't have a whole lot of time tonight either. Got a phone call with some folks after dinner, and then I'll got a little bit of stuff to do with my kids after dinner and the young kids' bedtime. Start a new D&D campaign for them. See how that all goes. Right, limit exceeded. I mean, alternatively, maybe I only run the Steam commands from my other account to prevent this switching between accounts causing any issues. They both have permissions, they both have access, they both are full admin, etc., etc. It seems to get very confused about my authentication. Slightly puzzles me because it is the same machine. And I was having no troubles running that script yesterday after one app authentication. Then I switch which login on this machine I'm on, and all of a sudden it can't seem to figure out what to do. Okay, well, we're gonna go watch an airplane real quick. At this point. What? Oh, I see. Okay, so if we have the screen shrunk down, this is our small size. So settings, small. We go to the game. That plane should fly every 5 or 6 seconds. It should fly at different heights. But they should never be off the top or below the bottom. I'll sit here and watch it for a little bit. Okay, so I'm not actually seeing that issue you were seeing the other day. We can go large scale. Maybe it's fine. Mm. Okay. I think we're probably fine. I think that's actually fine. Retested airplane. Everything seems to scale with screen size. Fine. Okay. This task gets moved down. Okay. Chalkboard doodad. I guess back to you. Okay. Doodad, chalkball. Okay. We're gonna change things, we do things a little bit. We have a target position. This is where the mouse is when we're dragging. All this is working fine. Last X, last Y. What if instead, well, let's not store that at all. Let's just see what we've got. As I recall, the drag drop wasn't working too badly. It was when we aren't holding the mouse anymore. So let me just show you what we got here. So what I'd like to do is be able to grab it, like toss it, and have it bounce off the walls. Okay, that's just wrong, 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 wrong. Okay. Float m underscore velocity x. velocity y. Excel x and y. Oh no. Velocity magnitude. That's all we want. No, let's do xy. Okay. Underscore max velocity. Let's just say it's like 50 pixels per second. Just for now. Okay. This is the traveling vector along the x and the y axis. This we will need eventually. Because we have to normalize this. What I want to say is velocity magnitude, which is different from the vector magnitude from position to target. Del x, del x, del y, del y. If velocity magnitude is less than underscore max velocity allowed, our velocity magnitude gets clamped. Easy. Oh, if it's less than, okay. Mag plus equals underscore Excel. If we're greater than, we clamp. Okay. So as long as it's held, it can accelerate towards that point. Then we normalize Vx, Vy, our vector. Vx over V magnitudes, that normalizes that term. Then we multiply by vel mag. V sub x, V sub y, if it's very small, we don't do anything. Otherwise, We add it. And then we move to that position from our current position. Let's try that out. Okay. We do not have last anymore. We kill the velocity. Oops. Finish the build. Okay. Almost there. Hey, Tar513. It's all about the weak math according to ChatGPT. Well, that's super insightful. Weak math, huh? What would we do without AIs around to tell us what to do? Weak math. All right. So I right click, and it doesn't start moving. Curious. Mouse button, right button. If it's contained, then we say we are held. And we say what the target is. Mouse move. If we are enabled and held, we update our target. When we release, we are no longer held. In update, if we are held, we want to go from our current location to a target location. So vector magnitudes for normalization later, we get the velocity magnitude. If we're less than our maximum velocity, which is a constant, 50, then we accelerate. Plus equals acceleration. If we're too fast, clamp it. If our velocity magnitude, max accel. How much was our accel? I don't think we set that. Accelerate at 25, probably more. I don't know. But this also needs to be scaled with time. See how that goes. Is that like a reference to a particular article or something I've not seen? Weep. Alien species from the short film titled Axtrump. Huh, never heard of it. But I don't see Fweep Math specifically coming back. So it's probably not. So the Google AI is not making references. Crazy. How disappointing. Okay. Right click, there it goes. Whee. Okay, acceleration is very, very slow. And our max speed is not all that fast. Oh, yeah. We want that way snappier. 100 pixels per second max. We're going to speed up a lot faster. We want to be at full speed in a second, right? Maybe turn that plane back down. Okay. Well, that is a little bit jumpy. It doesn't come off the wall easily. That's actually a little odd, some of that behavior. Yeah, it's not great. I don't like it. Why? Hmm. I don't like these movements. And the fact that it hits the wall and stops is okay, but then why does it take so long to come off the wall? We're no longer storing last position. Velocity magnitude age of S. Thanks. Time for bed. You have a wonderful evening as well. See you tomorrow. Or here's an alternative. If the mouse position is outside the bounds of the chalkboard, it's considered released. Bonk. It's like if I consider it released there. Yeah, this is not great. Hmm. Huh. Not much good in here. M or A. Oh, here we go. There it is. There's our key. TROS P. B or Y. It's B or Y. So it's soapy. So I don't mind so much that it does weird things when I pick it up. That's kind of to be expected at this point because we aren't modeling the physics when you've released it. But it's probably Y. Well, it may not be Y. That's interesting. FG, GY, BY. We only have room for 2, so it could be GB. It cannot be Y. It could be Y and then something otherwise. Oh, let's go with BG. Bingo. Oh, I got lucky. Yeah, that just doesn't look good. Okay. So what's the best way for me to do this? Hmm. Yeah. It's not that it's not following. It's not that I can't do other things with it. I don't want to do any actual physics at this point. I just want to fake it enough. I mean, do we do physics? Is that how we want to do it? Hi, son. Oh, jeez, son. He's up there, dude. We're out of hot water already. Okay. Do we go full physics? Let's ignore that for now. Let's just, well, let's see here. Physics, gravity. Okay, let's do this. Let's just go full physics. Let's make a small Euler integrator here. We have a mass. We have forces along the x-axis, forces along the y-axis. we have float underscore force equals mass times acceleration. Velocity x, velocity y. Then we have its position. And we don't even do a max velocity. We just do force equals mass times acceleration, velocity, and our current position. We will also need gravity. Float underscore gravity t. I don't know how much. Give it a mass of 1. Force x and y are 0. Let's start with initially. As is our initial velocity. Okay. If it's held, that's one set of physics. Basically, the force is this. The further away we are, we want more force. So force on the x-axis, force on the y-axis. Whereas if we let go of it, then we have underscore force dot x equals 0, force y equals gravity. Accel x equals force equals mass times acceleration. Therefore, force divided by mass is our acceleration on the x-axis and the y-axis. And underscore velocity x. Now this is not going to behave well at the edges, so velocity x equals plus equals acceleration along the x-axis times time y. Then we get our position. This is just simple Newtonian physics. And really we're just picking the forces based on where we're at. We do want drag. So the direction of its previous velocity is a force. Vel x minus equal or times equals 0.9 times delta t. This is a fast, cheap, early, dirty way to get drag. Okay, underscore velocity x less than 2. Velocity y less than 2. We don't do anything. Otherwise, we update our position and move on. So simple Euler, first order Euler integrator. Just to try it. Mouse movements can be erratic, but we're stretching the force out potentially over time, so maybe it's fine. We can add more mass to the ball if we want it to accelerate slower. Huh. Nothing. Nothing. Okay, that's a little bit awkward. Why? Oh, why is from the top of the screen down? So gravity should be... I don't know. Doesn't matter. Gravity is positive in this frame of reference. Mouse press. Oh, also at the end of every frame. Oops, we need to zero out our forces. For the next frame. Maybe that we're accelerating too fast and it's just hard clamped. We just can't even see that it's hard clamped. Okay. No good, no good. All right. What language I'm in? Held. Released. Force is the distance between where we are and where we want to be. The further away, the greater the force. Otherwise, we let it fall. Acceleration is force divided by mass. Then we zero. Velocity increment by acceleration. The velocity scaled. Oops. Times delta t. Since it was being stored with a timescale as velocity, that would not work well. basically the delta time will be compounding far faster and basically approach zero. What are we making? Well, we've made a basic logic word game, and we're trying to add some little doodads. So it doesn't need to be high fidelity, cool, rugged kind of for integration methods. We're just adding a little ball to the chalkboard that you can play with while you're thinking. So this is not all final art at all, but it's just a word deduction game. So a little homage to a 1992, 94 game that I played when I was a youth. Much codes. Then you can make logical deductions and guess the word. No duplicates allowed. That is basically what limits your inputs. A is in, T is out, S is in. Nope. Yes. No. No, not F. Next. No. Interesting. Jacks. Logs. Maybe it's like Nash. Perfect. Anyways, while you're thinking, the idea is that you can do different things to play around with this ball. Like you could toss it and it would bounce off the walls of the chalkboard. Just adding little doodads. There's like a paper airplane that flies through every 1 to 3 minutes. For no reason. Final art's coming. Music is coming. No game engine. Just having fun. Is Python good for making 3D or 2D games? It depends on what you want to do. Python is great for all sorts of things. I like to use Python for like prototyping and for learning new concepts, because for me the thought to implementation time in Python is very, very low. If you want to build something that is high performance, I would say don't use Python. Now there are some game engines built on top of Python, or game-like engines built on top of Python for your rendering loops and things, but those are going to be implemented mostly in C++ with a Python on top of it, basically. Yeah, and again, it kind of depends on what you want to do. For me, I want to do this educationally. I wanted to do it with no dependencies or minimally. I would like to modify Minecraft Pi. That's why I ask. I'm not a Minecraft modder, but whatever languages they support, Python would be great. Minecraft Pi mods. I don't know what language they use. Is it all Python? If it's Python, then yeah, you're fine. Ooh. Let's see here. Let's see here. Sonic Pi and Python. So yeah, I think it should work. I don't see any reason why not. As long as those bindings are supported. Let's see. Minecraft Pi with Python. I'd be surprised if there wasn't some bindings for Python. Yeah. Yeah, so there's Minecraft Pi. Oh, the project is archived, but they don't update it anymore? Interesting. So Raspberry Pi is telling me they've archived it. But you can still use it. Huh. Cool. Yeah, but whatever you want to build something in, build it in that. If you want to master the craft of programming, or if you want to build a high performance game, I would say Python's probably not the number one go-to for me. I recommend if somebody wants to master programming, they should probably learn first C and then Lisp. And if they want to get really, really serious, then they should learn assembly. But that's only if you want to be like crazy good. If you just want to get a project done, yeah, sure, Python. Use Java. I have my issues with all the languages, but you know, you do you. So why is this not updating? Doodad, Chalkboard. Delta time. Current position. For being held, follow the mouse. Once we let go, just gravity. Acceleration, force, velocity equals acceleration plus times time, because I have to scale that. Okay, so let's see here. If we rate limit ourselves with vsync, we can output something here. So let's do an update. Update force. Acceleration. Velocity. And we just stop the damping right now. And just log it. Okay, so m underscore force x, m underscore force y, m underscore excel x. Oh no, just excel x. Excel y, velocity x, and velocity y. Thanks to me. Yes, sorry, not much more help. I don't haven't done any Machine Pi or Minecraft Pi. Good heavens. Yeah, let me know if you have any questions. I'm happy to talk you through my project or talk about just about any topic, as long as it's won't get me in trouble. I don't have such a big following yet that I have to be like, no, stay on target, stay on program. I can pretty well talk about just about anything, and it doesn't really cut into my work time that much. So just let me know. But oh, get out of here! Get out of here! Stop! 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 Velocity negative whatever because of. Well, that's a little interesting. That downward velocity keeps growing, even though it's not going anywhere. Which we can fix, but that's the point. And for now, maybe we do just fix that. Let's see. Go to Chalkboard. Now let's move update position. If we have to clamp, if we hit the side, all we're going to do is m underscore velocity x equals 0. We're just going to clamp it. We're just going to stop the velocity. We're just going to make it thud into the wall and kill it. It won't look terribly realistic, but it'll be fine. Then I need to remember go to settings and turn on vsync so we don't fill up our log, our console. There we go. 60 frames per second is more than enough. We don't need to see 1,000 frames per second of console output. It's not helpful. And it slows us down quite a bit from that 1,000 frames per second. Okay, settings first. Settings first. My autopilot, what I click on, is pretty automatic these days. So vsync on. So now we're loaded to 60 frames per second. And it crashed. Its gravity is on. Okay. Sure, let's run the debugger. It printed once and then quit. Did I do something wrong in the print statement? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Oh, there we go. Okay, and now if I right click and drag, oh, it has a velocity, sort of. Let's see, can I arrange this so I can see what's going on? If I right click the ball, Y should be very negative. So why is it not? Oh, whoa, 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 there it goes. Okay. What? Acceleration. But it's not clamping that velocity. Why is it not clamping that velocity? This X, I guess it hasn't hit the wall, but it's not moving this much. So these velocities are bogus. Okay, we are going to limit our maximum velocity. I have no idea what. 200. Well, we'll do that. Just because I think this is not good. Position. All right, let's start up with a new build. Well, that's building. Little restroom break. So build complete. Oops. Run it again. Velocity tries to grow, but it doesn't. Let's right click. Oh, there it launches. Bonk. And it's going to slap into that wall. Bonk. I thought we bounded that velocity. Why is that velocity going crazy? X is greater than 200. Oh, less than. That's negative. But that still doesn't explain why it doesn't just take off. That velocity should be a thing. Oh. If the absolute value of that is less than 2. Floating point absolute value. Since we're mostly interested in going negative, that actually makes sense. Ugh. So many small pieces here. I'm not thinking clarity through. The old streamer brain is getting me today. Okay, now we grab the ball. Fling, and then it flies, then it hits the wall, donk, and falls. We launch it again, small hop. It follows the mouse. Some could argue that the acceleration is a little low. Our clamp on speed is probably a bit much, but that is not the worst. Okay. So velocity max. That's only one component of the velocity anyways. Gravity. 200 mass force. Velocity. You know what? Let's not clamp that at all. I don't think that was the issue. Acceleration. In this case, let's take this force times some multiplier. Like, I really want it to follow that mouse pretty tight, so let's strengthen that a lot. Or at least tighter. You also do it as a square, so the further away you go, the faster it accelerates. we are slapping into that wall. We have ways around that. Or not around it, but ways to make it look like it bounces off a little bit more. All right. Then we go click, drag. Oh, what is it doing? Okay, so that damping factor is too much. Or it also needs to be scaled by time. Or it's actually this 1.0 minus my scale factor times delta time. Oh, but that's more like it. So if we want to preserve 90% of our velocity over 1 second, this is our damping factor. Yeah, that would scale the damping with the frames per second. So that would be probably better. We also probably can go to settings and flip us back over to VSync off. Oh, I guess we didn't save that setting. Okay, that's fine. Okay, blah, blah, blah. Whoosh, bonk. Grab it. Flame. Okay, that actually feels a lot better. I think if we remove the console logging, this will be just fine. We're fine. I don't think I have enough room to really speed up that much. Okay, which brings us to the bounce. Smells here in the journal. Better dragging, fix the physics. Those all feel better. Animating and oh, no. Not fix physics. Fix physics has 2 parts. Drop. Bounce. We did add damping. Damping. Stationary. That's the thing we still have to add. So I would argue these 2 are probably not done. So let's just double check that. How does it? Well, let's do it with the build. Those lines not logging out, it might be a little smoother. Hey, Pat, what's up, brother? I'm doing great. How are you doing? Been a while. Been quiet. Been busy. Life gets in the way. That's what I have to assume. Everybody has such busy lives. I don't know. I don't think it's good the way the modern world is going. Everybody is so busy and consumed with life. And by life, I mean usually filling out middle manager paperwork BS for bureaucratic nonsense, but not all of it. Like we just overschedule or whee, there goes the ball. Touch, touch. Gravity takes over. Fling it that way. Dunk. Dunk. Wee bonk. Okay. That doesn't look too bad mostly. Okay. Let's save that work. We have it dropping. We have some damping in. That worked well. Chalk, ball, row, drop. We're looking better. Let's see. It's not quite true. Chalkball physics improved with first order Euler integrator. Drag and drop. Looks okay. Drops all velocity on impact. No stationary yet. I've been really busy with my portfolio trying to find new work. Yep. Whether it be voice work or software development or AI tutoring, just trying. Yep. Gotta find something, man. You need purpose, you need action, you need insurance, all the stuff. That's what I mean about life just being so full of stuff. Okay, so let's make this chalkball better. Stationary. When it's stationary, it's not moving. Let's see here. Where do I leave it stationary? There's got to be a place here. There we go. Oh. Alright, well, who knows? We can just leave it as is. It's fine, I'm sure. Alright. Maybe don't worry about stationary. Let's fix the bouncing. So here, if we hit X, if we're less than X, it's bouncing us. But instead, what we should do... Oh, okay. So if we have an X velocity and we hit the wall, we should return by the amount we would have gone through, the amount of penetration. Then flip the velocity's axis. So how much would it have penetrated? X is less than, so that means that this is our left edge. How much further are we past that? So left edge minus X is our delta X. That's how much we would have gone past. So we just come back that same amount. It has to reflect around this thing though. So how much did we go past? Bounded X minus X when X is less than. Tells me how far. Actually, let's just keep this simple for now. It might be good enough, even at. Yeah, we just flip it. Let's just flip it. Instead of flip it. We'll just see how that looks. Yeah, you got any good leads? I hear, and my own experience has been that it's a very rough job market out there right now. The big FANG companies have laid off thousands. So the competition is very, very stiff. And that also means they're not hiring nearly the rate they were. So if you want to get into FANG, that's not really a thing right now. Bling. Bonk. Bonk. Oh, that's not bad. Oh, look at that. Donk, donk, donk. We need a faster gravity. bonk, bonk, bonk. We need faster accelerations. Whack. Oh, that's not too bad though. Oh, that's starting to be more like what I want. On an impact though. Okay, so we want more acceleration. More acceleration. Gravity. We want more gravity. Like, a lot more. Gravity. This acceleration towards the mouse. Double that up. We could square it. I don't know how I feel about that. On impact, we want to flip it and bleed some. Although that damping, 90% damping. Maybe go like 9.5. 9.5. We don't want to damp a lot. But then these, I do want to like noticeable drop in energy, right? Times 0.75. Maybe you lose a quarter of your energy upon impact. Oh, that is 0.75. Yeah, it's going a lot better once I put in a first order Euler integrator. That's much cleaner. Yeah, it's terrible. Yeah, it's just not good. It's not good. Like, I applied, I don't even know how many. I don't know if I was up to hundreds of resumes, but it was probably on the order of 100 resumes. Sent out, maybe got callbacks from half a dozen of them. Most of them never even sent the reply, oh, we're not interested, right? Or we decided to go another way. And then that led to maybe 4 or 5 applications. Donk. Oh, that's not too bad. That's pretty satisfying. Donk, donk, donk. Oh, oh, that's not bad. Whoop, bonk. Okay, that's kind of nice. That feels good to play with. Nothing to do with the game at all, just... Oh, wait a minute. You can cheat. Whee! Oh, that feels pretty good. I like that. Little toss. Donk, donk, donk. I like that. I think we're going to keep it. Do we want it to make any noises when it bounces? Nope, I don't think we want any sounds. Do we? Unless the velocity on impact is greater than some amount. I'm not too opposed to that. Do I have a bounce sound? Okay, let's see. Well, plus the number of like fake job postings that aren't even real. That's maddening too. You'll apply to a whole ton of stuff and they'll never respond, and they're just shadow job postings. It's not real. That always makes me mad too. Don't waste my time if you're not actually hiring for a real position. I interviewed. They're like, oh, we don't have a specific position we're trying to fill. We're just looking around for potential talent. It's like, no, shut up. Shut up. You don't get to do that to me. What if we don't bound our target? Sorry. I'm easily distracted. That means we could fling it across the room even though it's bounded to the chalkboard. That doesn't look too bad, even though our bounce resolution is not great. Like if you wanted physical verisimilitude, the time between the frame where you're before the wall and the time after the wall, you want to basically compute the distance traveled into the wall and reflect that out, because you'd hit, and maybe, 0.75 of that velocity, since we're eating some of it up on bounce. Maybe slightly less damping. Or less damping if it's being held. If it's not being held. That could make for more acceleration. Maybe just a little less damping. It's actually amazing how much of a difference that makes. But on impact, maybe we actually bleed more. Bleed more of our velocity on impact. That should cause it to bounce less times at the bottom. I don't know, we're just playing around. Trying to get the right feel. Uh-oh. That's not good. Oh, I don't remember what. Oh, it's almost time for jalapeno poppers, though. Do I need a bounce? Do I have a bounce sound in my own audio library? Sure I do. Then any velocity over, I don't know, 10 or 20 would make a little bounce sound. A little doing. Okay. Oh, that's nice. Dunk, dunk, dunk. But it's not in your way of play. It always falls to the bottom. Dunk. Oh, that's kind of fun, actually. Let's put the ball in the corner. Ooh, too much bounce. Ling. Bong. Hmm. I'm gonna add a bounce sound. It might be more satisfying. Okay, let's see. Do I have my audio still up somewhere? Linked somewhere? Nope, not that one. That one? No. Okay. Let me go see if I can find it. Then we can look for a bounce. Not a ding. Where would that be? Probably in my resources sound. Oops, let's go to the player. Now if I double click, if I load this file. Okay. Maybe pop. Okay. I guess I should share this screen, which is always a bit of a chore with Brave for whatever reason, and OBS. They don't play as nice. Okay, so let's go to the old browser. It'll only grab it if I put the title, the Twitch screen up first. Okay, we ready? We need some, I'm pretty sure this shares the audio. Capture audio. Okay, so you should be able to hear what I'm hearing. So let's see. Nope, don't like it. Pop. Oh, that's not bad. Click low. Oh, I want this one for popping the bubbles. Like, I want the bubbles to float around and, like, color shift and fun things. Pop. Nope, this one, pop high. Oh, pop mid. That sounds good. Pop mid. Nope, this one is perfect for the bubbles. That's coming up. But that's not the same thing as a boing. I would like a boing. I don't think zaps are it. No. Nope. Nope. Pads? I don't think there's like a... No bounce, no boing. I just want like a short, quick little boing. Boing? What goes boing? It could be cartoony. Blink? No. Marimba? Marimba. Well, that's not a bad donk sound. Let's see here. I don't want chord, I want like a note. Marimba, kalimba. No. Note. I'm pretty sure marimba has a note. Pipe note? No. Marimba note. No. Does that sound like a bounce? Music pipe note. Ding every time you bounce off of a wall? Music pipe note. Let's write ourselves a note. Door stopper. Oh, let's see. What has JTL got going on here? Click. Which one is this? Is this the boing boing? Nice. Nice. Something like that. I forgot where that tab was. This one. Music pipe note. Boing. Yeah. Etc. This one has like door knobs and things. Let's see here. Bounce. Boing. Nope. Not that squeak. Whoosh. Yeah, I think some of those other boing sounds are just too long. Like, nope. I need something that's like, maybe that's that music pipe note. Yeah, all these are too long. Digi. I don't like any of these. Pardon me. Clicks. Not sure what I'm really. That's a belding. That's. Chime bell ding. We could go with like a woodblock sound. Yeah, I don't see any of this being very good. Even that seems a little long. Well, I still like this one for the bubbles. I like that one. Well, let's just steal the pipe one. That's marimba. I thought there was like a marimba single note somewhere. Marimba. Nope. Nope. Note. Marimba note or pipe note. All right, let's go grab the music marimba note and the pop music marimba note. The higher note's going to be more irritating over time. So let's go grab that music marimba note. If I can remember where to put it. Okay. Resources, sound. I don't want to use too many sounds off of another web page where I have to give notifications. Something simple like this, I think I can get away with. So, music, marimba, note. Copy that in somewhere. Just a minute. This is not that interesting to watch anyways, so otherwise I'd share the screen. Assets, sounds. Music, marimba, note. So let's. The other one we want is the pop mid. Let me go grab that one while we're here. Pop mid. Marimba note. Make sure I didn't move it. I just copied it. Note. Okay. All right. Then we stop sharing the browser. Which means I can put it back where it was. That goes away. All right, now, oh, no, not that one, not that one. Only I need to see what I'm doing. Problem with too many windows. Okay. All right, assets, sounds. And what we've got here, there's the music. This music placeholder song can actually go away. I don't think we use it anywhere. I'm going to delete that out of my library. That'll save us up a little room. We want bounce.wav, which is a sound effects channel. I think it can be not too loud. Assets, sounds, and that was music, marimba, note.wav. The other thing we want is pop. And that one was pop mid in the files. Element OP, pop mid, music, marimba, note. I'm gonna grab those. Oh, this is gonna be painful. Tools, embed. Oh, bin. Tools, bin. Embed wavs. WFT. Back up we go. How long does that all take? Oh, that's not helpful. The music is what's taking all of our time, really. But then any bounce that exceeds some amount, or that exceeds some velocity, just plays the boing, or the marimba note. But yeah, we'll see how that looks. We did put a lot of test songs in here, didn't we? Okay. So we want to go to chalkball. So here's one question. Do we want 3 chalk balls? No, they would interact with each other, potentially. I don't want them bouncing off each other. Do I want them bouncing off each other? It's so tempting. No, nope, 1 chalk ball. That's all you get. Velocity magnitude equals magnitude squared. We're not gonna vel x times vel x up. I really don't want to compute this if we bounce. But it's the original velocity x we need to keep track of. So float vx equals vel x, vy, v velocity y. Vy. Okay, now we need a Boolean bounce equals false. All of these say bounce equals true. So if we're in a tight corner and it hits both at the same time, it's only going to play the sound once. Bounce equals true. Then, if we bounced, then we compute the velocity magnitude squared, which is Vx times Vx plus Vy. This is the velocity at the time of impact times Vy. If velocity magnitude squared is greater than, no idea. We're just going to play with a couple of ideas here. I'm going to say if it's greater than something, we play the sound as loaded. So sound star sound. We got chalk ball. We need the scheduler. And we need sound, and we need the sound warehouse request for that sound. Equals scheduler get sound from the sound warehouse assets we want bounce. I think that's what I called it. Oh. No, that's not it. Sounds. Bounce.wav. Sound play. Here, sound set volume will be sound volume over 2. We can basically compute a volume for our velocity or for our sound based on how fast we are when we hit. That might be nice. Well, let's just see what 10 and 20 gives us. We should be able to hear it when it falls to the ground. It crossed that threshold on some small bounces. All right, let's just see what happens. Oh, it may just be too annoying, but it may also make it more satisfying. Like the movement now feels good. Sometimes adding sound just makes it have that much more gravity. Oh. What build did we run? Okay, no, this is expected. All right, our sound warehouse will take a while. Maybe now is a good time for me to get jalapeno poppers. Jalapeno popper run. Be back soon. While we're waiting for that to build. All right, be right back. Just hold on and we'll do some testing when I get back. Okay, we are back. Fix this, whatever it is. Bounce is not a member. What? What? This bounce not a member. Oh, oh. Oh, not capital. Is that why? Oh. We grab it twice, depending on our speed here. We're gonna try this out. Question, what is our kind of our maximum velocity on impact that we can get? Maybe that's the better way to do it. We should scale our volume based on our percentage of our theoretical maximum velocity of impact. Ooh. Here we go. Let's just see what it does. All right, let's go bounce a ball. We'll keep it simple. We'll just launch it up into the air and let it bounce off the ground. Oh, it dinged. Okay, that's awkward. Okay, all right. Honestly, that's not the worst I've ever heard. It bounced. Keep that. If velocity magnitude squared is greater than, say, 1, I don't want it to log. I want it to log it. Let's just compute it. Let's just capture it. Chalkball.hp. We're just going to capture it for ourselves. Float m_max vel mag squared. We can delete this number later. So in the beginning, this is 0. If velocity magnitude squared is, oh, let's see here, m_vel max vel max squared is less than this latest thing. Let me just assign it. Let's say, yeah. Then in the destructor, when we delete this thing, max observed velocity magnitude squared. Take that for a little test drive. That ding doesn't sound too bad yet. Wow, why are we in Python mode here? This is not Python. That gives me time to eat some poppers here. So good. Okay. So it's not dinging, which is good. It's not dinging, but that's okay. We actually kind of expect that, right? So all we want to do is whip it around a bit and see what our maximum velocity looks like. Okay. Now destructs. Boop. Holy smokes, that's kind of a big number, actually. Really? That's fine. Okay. So if we round that up to, say, 20 million. Sound. Sound up play, but sound, let's see. Set volume equal to sound volume times 20 million over current velocity magnitude squared. Other way around. Whoops. Then play. For max. Okay, we'll see how that sounds. 20 million is this, what, square root of 20 million is something. 20, 1, 2, 3, 1, 2, 3, square root 4,440. Okay, all right. That's actually kind of fast. I would not expect that to have been my maximum velocity. To be 4,000 pixels per second. But we are also scaling by 1,000 frames per second in our simulation, so. People can always turn the doodad off, so it doesn't matter too much if they don't like the sound. Failure. Oh. 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 It shouldn't be bouncing for multiple frames, though. It's basically one bounce per frame tops. We have to think about that for a bit. There's the ball. Okay, now toss it. Okay. Actually, can we make this relationship less linear? Here, let's do this slightly differently. All right, sound warehouse, get volume. Sound warehouse, get volume. Of this asset. And our volume times equals velocity magnitude squared over some huge number for some reason. If the volume is less than some tiny amount, don't do anything. If it's greater than that some tiny amount, 0.625, 1/16. Then we do this. If it's quiet, we just don't play it. Let's see how that does. I think we're super close. But I would like not to run out of sound slots when it's landing. Oh, it's not playing any. So 0625 is too much of a threshold. And that volume is greater than 1. Volume equals 1. So what is this threshold then? What do you think? Like, I think it's falling off too fast. So maybe we just go down to 1 million, which is 1,000 squared. It's less than, it's like 3125. So 1/32. Alternatively, I don't know, let's just play with it for a second. See what we get. I don't know what that quiet threshold would be. Okay. All right, maximum volume. Just make it 0.6. Our minimum volume can be actually quite a bit lower, I think. So we'll just go like that. See what we get. I'm still not sure how I want to animate the ball leaving and entering the scene. That I just don't have a visual for. Maybe it just fades. Okay. Toss. Not bad. Oh! Okay. We are still running out of sound slots. If we double the number of sound slots. Or, actually, you know what? Anything below that was a little bit on the quiet side. Maybe 0.02 something would be fine. 0.6 seemed a little loud. 6 was fine. High velocity stuff. Maybe we just make this like 500,000. I don't really want to add more sound slots if I don't have to. Actually, $16. Let's just double it. Okay. There we go. Okay. We could make it a wood block sound instead. Like a knock. I would like to make the bubbles today. Yeah, seems okay. Oh, there it goes. Hmm. Oh, we said 0, 3, 1, 2, 5. So maybe we went with this. All that still playing sounds too quiet for us to care much about. Those jalapeno poppers were too good. But I'm refueled, ready to keep going. Still have some gum. Ready to go. I'm just going to change the threshold at which we don't play the sound. Side up. Part of me wants to bleed a little bit of the orthogonal axis off on an impact. So when we flip this, we also do velocity y times equals 0.9875. What this is going to do is when you're rolling at the end, it's actually going to speed up how fast it stops rolling. I actually think this damping here could be even less. 875, 9875. So as it's flying through the air, it doesn't slow down as much. Maybe go 925 or something. 925? As it's flowing through the air, I want it to fly a little more, but as it hits the walls, I want it to slow more. I want to slow less in free flight and more on impact. And we don't want to overwhelm our sound things, whatever they're called. Oh, that was better. I actually think, what about this then? On impact, if it bounced, if the velocity magnitude was greater than some amount, so in other words, here, we drop it. When you bounce it off of a wall, loud enough to play a sound, you lose the ball. That way you can't do what I'm doing where I'm dragging it back and forth wildly. Long after it's impacted. So if I drag it hard over to the edge of the chalkboard, it flies off, and even if I hold the button down, it doesn't. It does not consider it held anymore. Yeah, I think that's a good idea. Okay. Whoa, 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 whoa. Oh. Interesting. Okay. So I can bring it over here. But as soon as it hits, it's done. Okay, so what this is telling me then is not this. This is wrong. Max component, max velocity component equals Vx greater than Vy question mark? Oh no. Bounced X, bounced Y. If it bounced. Which means bounced on the X or bounced on the Y. Let's see here. High velocity equals something if it bounced on the X. And the high velocity equals or bounced X if it bounced on Y. High velocity equals is bounced Y greater than our current high velocity? If so, then we take bounced Y, otherwise we just keep high velocity. Now, volume times our high velocity component over something. That's a question mark, by the way. Obviously. Okay, ready? Here we go. Launch. Now no sounds are playing. Oh, okay. Fabs. Oh no, not that. Velocity of X. If fabs velocity of Y is greater than high velocity, then we take this. I bet those negatives were killing me. Okay. Now, if I was like a sound engineer or an actual, like, I don't know what else. If I had some formal education at all or training in what I'm trying to accomplish here, this would probably be faster, but instead we're doing it by trial and error. Toss. Nope, no sound still. Huh. Curious. Okay. If we bounced off the X or the Y, then we take our high velocity. If we bounced X, then we take the X velocity. If we bounced off the Y, we take the question. If the magnitude of our velocity on the y-axis is greater than our highest velocity, then we take, oh, that's the bounced y again. Sheesh. B sub y. Okay. And bring it up and just drop it. All right, it's not quite right yet because we're doing this, which is not quite right. It's close to right, but it's not right. Is it? Let me think. Okay, maybe we do this then. Maybe we do target that again. You get that first silent ding. Okay, now I can. Hmm. So that fixes one thing. Maybe we don't let go. I was trying to get the look and feel right. Like if there's a, should be as intuitive as possible for the user to play around with it and not feel weird, like the auto release when you didn't let go of the mouse. And maybe we're over damping on the, like that first ding. Maybe we don't damp the orthogonal axis. Maybe that'll feel better. Just seems to die so fast when it's rolling on the ground. Don't like that initial ding. That's pretty satisfying, not gonna lie. It's doing my frame rate. Not that much. This is like the only piece of the whole scene that's actually computed every scene, every frame. Not running out of sound. That seems okay. All right. Will it be a little more freewheeling, less constrained than? All right. I like that. That sounds good. Feels good. We're gonna call that good. Let's do a little bit of cleanup. Ooh, is it though? Is this what we really want to be at? Okay, we have some constants here. Damping is this. Let's put this up here. Damping. These are essentially constants. Come on. a little code cleanup here. Damping factor. So that's one constant we need to get rid of. So if our velocity is close to 0, we just clamp it to 0. Okay, what else we got here? So that way it doesn't accumulate while we're at rest. This thing. Maybe we do the elasticity. Maybe we make elasticity a thing. Elasticity. The more elastic, the more it's going to bounce. Let's play with a different one. Elasticity. 0. Let's try 7.5 instead of 5.5. 0.5 elasticity. We could also, on loading the game, set these parameters. We could change gravity, damping, and elasticity. I mean, it's essentially free. It's cheap, easy, free, and we don't have to do much to make each time you load the level feel a little different. Maybe we do that. Okay. It'll bounce longer. Not bad, not bad. So if we just seems good. Okay. Do we want to randomize those values on startup? These 3 values right here change the way the whole thing plays out. But would that change the feel too much? We leave it as constant for now? Maybe we leave it as constant for now. Let's not randomize it to start with, I guess. Is that true? Oh, so many difficult choices. Let's leave it. Let's not overdo this. All right, animating into the scene. I've had an idea for the fading into the scene. And we start with it near the top of the chalkboard and let it fall, but it has to fade in. Fall and fade in. And I think at the end we just fade out. Set bounds. What if we put it at x0 plus x1 divided by 2, so basically halfway across the screen. And then y1 is y0 is less than, so I think we want to start it at y0. I'm going to try that. Get started. So basically it'll start at the top and fall down. But then we'll add a fade to it. I think that'll look okay coming in. Going out, I think it just fades out. It's probably the easiest thing to do. Did we not build it? Maybe we didn't build it. Oh. And actually, well, it shouldn't drop the ball until the level has finished loading, but that's not even the right place. So what's it doing there? Set bounds. Set position. Oh, it's this number. Ooh. Underscore bound x1. I wasn't looking at that part. Instead of that one. y1 is the greater, which means it's lower on the screen. So we want y0 y1 moves halfway up. Oh, of our, okay, I see. So we do want m bound y0. Okay. That's not the right position right there. Set bounds. That is something we do from game scene. right there. And then we set the position there, which seems unnecessary. Oh, what? Set position, okay. Set position. Kills the velocity. There we go. Then we update the position. I think we actually start off the level with it disabled, and only after the initial animations are over do we set it enabled, and then it can animate itself in. That is probably the right thing to do. Right? Bonk. Whoa. What? What is it doing? Why was it not updating the way I would expect? Oh my. That's a little bit odd, actually. Oh. What? What? I think I know what's going on then. Shoot. Shoot, shoot, shoot. In my update function. Top of a bounce. Its velocity is effectively 0. Then you set it to 0. Ooh, no good. You can't set the velocity to 0. Okay. I'm happier with that. For what? I think we start with it disabled. And there's another reason we're going to do this. Game scene. Scene enter. Game context. Use doodads. Chalk. I forgot what it was already called. Doodad chalkboard. There we go. Enabled equals true. And then it will start falling as soon as we start loading the next level. I'm also thinking the set enabled might allow me to put the scheduler in the right place to alpha blend that image real easy. So that zooms down, whoop, and then pop. There it goes. Okay, that's close, close, close. Chalkball. I want to say void fade in and fade out. These can be very simple. Okay, now, scheduler, get animation. Doesn't really matter. Animation set range. We don't really need an easing curve on this, I don't think. Set range from 0 to 1. And the update function captures animation, and it says I forget what it's called, quad underscore quad dot set texture quad. I've set alpha. That's the set color. All right. Color C0 equals underscore quad. Actually, first going to go full alpha to opaque. We're just going to range from 0 to 1. Set color to C. Okay. Give me a single action to play animation. And done. So that should be the fade in function. Fade out is all of this backwards. 255 to 0. Maybe we don't give it a full second. Maybe give it like half a second to fade out. And then that has to go somewhere in game scene when we're cleaning up. The exit before the chalkboard goes. We have to do it. If we're using animations, it just fades. That's all. Doodad chalkball dot fade out. We'll just see how that goes. Okay. The fact that the ball is moving at the start of the level means it'll draw people's eyes to it a little bit earlier. Like people might just see it on the chalkboard and ignore it. So we'll see how that goes. Okay, that's not bad. And leave. That did fade out. Okay. Let's just watch the fade in as it falls. Okay. Should we drop it like over here? I think so. I also think gravity needs to be higher. Double the gravity. Set bounds. All right, this is x plus some percentage of the way between these two, m underscore bound x, not times 0.75. $75 is probably not it. It's probably closer to 875, so 7/8. The 3/4 will at least be visible. higher gravity. We did double the gravity. And bonk. Well, that's actually pretty close. 7.5, so 8.75 would probably put it line here. So maybe we need like an 8.25. That is kind of satisfying. Right, so maybe 8.25, not sandbox. I don't want to go back to sandbox. 8.25. 5 o'clock. So we still got like an hour to start working on bubbles. We do the art. It's fairly trivial in theory. Maybe we just make it use one bubble and have it doing weird color fades between the hues. You know, the brightness and saturation pretty high. Well, that is pretty much right where we want it. Let's reload that. There it is. Nice. I think that's good. I think that's good. The fade in, the fade out, those are both fine. Okay, fade in and fall. Chalkboard. Now transitions into scene and out of scene. Minor behavioral behavior. Updates. Make it feel a little better. I think we're just going to call that one done. Boom. That marimba sound isn't too bad. All is done and working. Oh, the sound warehouse has to be checked in. That's why it's taking so long. We did update our sounds. That's a long one. Boom. Commit. All right. Now. Yeah, we could add some variability to that thing, but the variability is in how you play with it, I think. Restroom break. Then we'll start working on another doodad. All right. Be back in a minute. Okay, we are back. We did it. Chalkball is done. Now, some of that work on Chalkball is going to directly apply to the bubbles. So, doodad bubbles is the thing. Floating bubbles bouncing off walls. I like it. All right, today we're going to get art, color fade over time. We can maybe do some fun things with that. Multiple bubbles. I don't know if I have time to add movement. Movement. And then starting points. And I'm starting colors. And I'm starting velocity. Velocity, color velocity. Then we want to do a click to pop. The bubble itself is going to be very simple. Maybe we define a small sprite animation of a pop. I guess this is a right click to pop. I don't think I ever want the bubbles to change velocity. So there's actually simpler. There's no gravity, no acceleration. They just float around. Okay. That sounds like a plan. Sounds like a plan to me. So what I need then is GIMP. Let's bring up the GIMP. Once it's up, we can share it. There's GIMP right there. Okay. Now this is the ball. We want something like that, but that is not that. So make a new, no, not that one. Layer, new layer. Chalkball. Sure, it's fine. Where's the chalkball? Or not the chalkball, the new layer I just made. Huh. Not say new layer? Will it call it chalkball? Why would I do that? Bubble. There we go. Now, this bubble shall be a perfectly circular one. It can be, to start, about as big as that one. But we're going to stroke. Where's the brush? We're not going to stroke it so heavily. It's going to be like 4 pixels. It will be pure white to start with. Stroke selection. Yeah, much thinner line. Then I'm gonna make a couple more layers. 1, 2, 3. What we're looking for is we want to make a nice little bubble shine. So we're going to do that. I'm going to move this somewhere else, like maybe here. Oh, yeah, stroke that. Oh, no, cancel. Well, darn. What is it doing? I'm not trying to subtract. You motherless hobo. What are you doing? Replace the current selection. Good heavens. All right. All we're trying to do is that. But not quite so big. We need to shrink that. Maybe like that. Okay, stroke. Okay. We're going to come over. And we're going to do something like that. Then, lastly, we need to erase. Start at this one. Eraser. I need a big old eraser here. If we're only erasing on this layer, it doesn't really matter if we go a little bit far. Oops, a little far. Also undo. Undo is wonderful. We love undo. Does that kind of look like a bubble? A little bit? A little bit. So merge down. Merge down. Okay. Not bad, not bad. Just a tiny bit of eraser work here to, maybe not quite that much. Just to sharpen up those lines a little bit. Okay. Merge down. Layer to content. Put that right there. Save. I mean, we can put it just about anywhere here, but that's right. Save. All right, we export as scene elements. Oh, I know. I'm not trying to backslash. There we go. Okay. Now we export the UVs. No prefix, sort fine. Okay. 26 UVs. All right. And that's that for GIMP. That's the easy part. All right. Journal, we need assets, images. Tools, UVs. Tools, we just need this thing. The chalk ball should remain unchanged. It's basically that. Shell. Ooh, tools, bed. Bed PNGs. And out again. Okay. So we get our UV embedded in our data. Okay. Game scene. Where do we do the chalk ball? Fade in. We're actually going to turn that off. We're effectively disabling the doodad for the chalk ball. They won't be both available at the same time, so it's fine. Okay, now we need doodad chalk bubbles. Okay, what do we need? We need CMath? Not sure. I might not. We need game context. We need to find a texture quad. Image warehouse renderer. We're going to need a mouse press event, but not anything else, actually. Input. Why do I have input here? Oh, for that. Okay. That's correct. We need that. A scheduler to get our sound for the pop is fine. We do need time. Oh, that's the other thing I want to do real quick. We got a chalk ball. Time. In time, we distinguish different kinds of time. I want real delta real time. Easy fix. There we go. So basically, instead of working in scaled time, so if you're watching a replay, this chalk ball will still behave to your mouse under real-time conditions. So it won't look too weird. Want to make sure that was in there. Okay, doodad, chalkball. Fine, public, doodad, blah, blah, blah. Okay, we need an update in the render. We do need to fade in, fade out. We do need to set bounds. But we do not need a set position. We need a texture pod to start with. We're going to have more of them. We're going to keep track of our bounds. Bounce, press, handler. We don't have that, don't have that. We don't have gravity, damping, elasticity. Ah, great. Lost my internet again. I'm gonna go plug it back in. Just a minute. Oh, looks like somebody plugged me back in. Ugh. We kind of need to wait for this stuff to come back up. Okay, so each bubble needs. Hold on, I gotta go yell at my children. Just. Okay. All right, we're just waiting for the internet to come back up again. Slowly, slowly, waiting for the internet. More and more lights keep coming on the old router. Oh. Our bounds are going to be a little bit different this time. We're going to take into account the width of the ball in the initial calculation. We'll have to address that in the collision checking, basically. Okay. All right, internet should be coming back up. Stream should be resuming. And I think we're back in. Okay. 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 Now, picking back up where we left off. Which was here. Mouse press handler contains. That kind of matters. Update position kind of matters. Those need some updates. Okay, doodad, chalkball, CPP. Doodad chalk bubbles, not CPP. Okay, here we go. One question is, how many bubbles do we want? Do we want to randomize that as well? We don't care about that. We only want the mouse test handler. We'll start off disabled as before. Oh, we should rename that, shouldn't we? Bubble. Bring it the size the same way as before. We don't have any of those issues. We don't have any forces. We do have a velocity though. So velocity x, velocity y. So every bubble, we're basically defining the bubble here. Has velocities, float underscore color. We could do multiple colors. Start simple. Starting simple. Each bubble needs a special location. Underscore position x, position y, relative to this thing's size. In this case, we're probably going to make this size equal to whatever our bounds are. Let's update all this. Positions, velocities, color. Let's just go with a nice pink, right? Red. 200, 200. Maybe we have a little bit more bluish than green. 220, 230. 0, 0. Okay, doodad chalk ball. We are doing this. The structure, we don't have to do much here. We need a fade in and fade out. It's going to be different. But the idea is the same. I think fade out, maybe we just pop them all. That would be kind of fun. Date, our date function. There are no forces acting on the bubbles. Okay. This is not the position that's updated anyways. We'll come back around to that. Although we do need to, well, it'll be fine. Render, good function to have. Set bounds. We aren't doing this. Doing this. Okay, set position to x0, y0. Actually, just set a fine rect here to here, x1 minus x0, so our width, y1 minus y0. There's our height. There we go. So the set position is not quite the same thing. Handle mouse press. If we're enabled and it's a right click, contains, don't have held anymore. We don't worry about that. So this contains, can be more like the button, right? Chalk bubbles. Look for overlap with actual bubble positions. So that's a to-do. What else we got going on here? Atticus of Sparta, hello, my camera looks frozen. Oh, yes, thank you. My kids killed the power shortly. Let me restart that. Thank you, sorry about that. I don't tend to look at myself much while I'm working, so thanks. Also, welcome to the chat. Let me know if you have any questions or if you want to talk about anything. I'm building a game with no game engine, and it's pretty nearly done. We're adding some what are called doodads today, basically non-game elements that you can interact with, just to spice things up. So I'll show you an example. It's a simple game, no game engine, so we're like building everything from scratch. So if that's the case, then you keep the complexity of the game itself scoped very normally. So it's a word puzzle game, right? And you deduce from your guesses things like how much toads, ultra, evenly, rhino, cloud lines. Anyways, you deduce your words from that. But one of the doodads we have right now is this ball that's a chalk drawing. You can throw it. And it's just something to play with while you think, right? Something to interact with in the environment. There's a paper airplane that shows up periodically about every 1 to 3 minutes for no reason. Nothing you can interact with, but everything else on the screen is game elements. So it's like, let's have a couple of non-game elements just to give people something to play with. So there you go. So we're working on something else. Instead of a ball, we're going to do bubbles, the little float around the chalkboard. We made it out of chalk. Float around the board, changing colors, and then when you right-click them, they'll pop. So that's kind of what we're working on right now. So we're just stubbing out that class right now, bubbles. Come to think of it, we don't even really need this function here. It's a simple pass through. Chalk bubbles. Okay. Set bounds. Handle mouse press. Isn't going to do anything yet. We can just log click for now. Bubbles. Right. Click. There we go. Hot. So right now this is basically the information for one bubble. And we'll make it an array later. So we changed enough things. Let's give ourselves a velocity of like 25 and 25, so it's positive. We're going to start at 0, 0. We're going to change that a little bit in the set bounds. Const rectangle r dot. I don't remember the function name for that. Rectangle dot HPP. Middle x. So I'm just going to put it in the center to start for now. I just want to get something on the screen, really. Oh no. That is not how this is going to work. This is rendered relative to that. So 2 dot. So half the width and half the height. I don't have to worry about the x and the y. It will draw the bubble here. Although we don't need this position here. Center, center. Nope. The texture quad needs to be centered. We're also going to vary these widths and heights. Okay. So where were we? Set bounds. Quad dot set. We'll move to. Now the update function is pretty simple. We get the bubbles rectangle. We get our time. There are no forces, there are no accelerations. There is no damping factor. So this actually simplifies a ton. These will always be guaranteed to have a reasonable velocity because of our initialization. We just update our position. So I'm going to steal that from Chalkboard. doodad chalk ball.cpp update position. Don't actually need that. We don't need that. We only need to reflect the velocity and clamp the positions. Move to now L_quad move to. And that's basically it. The bubbles are actually much simpler. Well, to start with. Update, render. Okay, so a couple of things we have to do. You have to add it to the game scene. Chalk ball, chalk bubbles. There we go. Okay, then game scene chalk ball bubbles. It won't do much if it's not enabled, so it's fine. Chalk bubbles. Basically, all the chalk things have to happen after the chalkboard is rendered, but before anything else. All there is set bounds. Same thing for that. Chalk bubbles. Same bounds, same chalkboard. Doodad chalk bubbles fade in, which aren't really going to do much right now. And fade out, which isn't going to do anything. It's just going to do nothing. Okay. Is that all of it? I think so. Make file. We need to update our make file. There we go. Okay. Now we can build. I hope it just shows up in the center of the chalkboard. Even if it just shows up. That's all we really want. It may move in a 45-degree angle down, if I remember right. And it may bounce off the walls of the chalkboard correctly. That would be nice. It's kind of like the ball. There's so many things we could do that wouldn't cost us a ton, but might increase the variation. Could be interesting. The bubbles will not correctly be within that bounds a little bit, will they? It may not even compile. Update position. It does not know the width and the height of the bubble itself. So the bubble will go all the way to the edge from the center of the bubble, which is not ideal. Yeah, copy paste errors, things we didn't finish up cleaning. We don't have that anymore. That's fair. What else we got here? Position. Color. Okay, then. We were going to go to figure out some of the errors. Why is the color afloat? Shame. Okay. That may fix multiple errors. Okay. Oh, right. Easy fix. Okay. There's no Vx. There's only underscore velocity of x. There's no Vy, but there is an underscore velocity of y. There is no elasticity. Hey, we're close. Now to see what even shows up. All right, here we go. I don't see it anywhere. I don't see it. I would expect it to be right about here. So that's unfortunate. Okay. Now, fade in. Bubbles dot fade in. I'm pretty sure we're calling that some fade out. What else do we need? If it's enabled, it updates, which is fine. Render. Enabled, that's great. Set bounds. Okay, handle mouse press, don't care. Update position. Just from update. We get the quad rectangle X, Y. That's it. Update position. Move the quad 2 somewhere. So there's an update call. There's a render. Set bounds. Fade in, either way, fade out. Just rebuild everything to make sure it's clean build, I guess. We have to finish the bubbles tomorrow. Not as far as I'd like. Having my internet shut off again, a definite setback. Meanwhile, tomorrow I'm gonna try and, or tonight, no, I don't have time tonight. Tomorrow, I didn't have time today for my workout, so if I have to do my workout tomorrow morning, which means I'll have less time to do other things. So I don't anticipate having any real time to work tonight. So many things to work on. I haven't even started marketing or building my YouTube channel for this company. Because I need a couple of like YouTube videos. One of them is going to be a big pain. Basically be a time lapse of development over the last 20 however many weeks. Coming through all of that for reasonable time lapse information, it's not going to be great. It's going to be tedious. I have nephews. Maybe nephews will work for cheap. I don't see the bubble here. All right. We've really stubbed things out. I think we're going to have to call it there. It's almost 6 o'clock. Time to get going. So let's document what we've got and call it quits there. Art's good. Oops. Chalk bubbles stubbed out, not showing on screen yet. Debugging needed. Wait a second. What's my initial color? Oh no, that's fine. Okay, well, never mind. Don't know. Alright, chalk bubbles are stubbed out, not showing on the screen yet. Compiling, not showing on the screen yet. Chalk bubbles stubbed out. Compiling, not showing. There we go. All right, we're gonna call it there. Tomorrow we'll pick up right there. We're gonna do the chalk bubble doodads. Those should not be too complex. It'll be great. Make a nice little satisfying pop when you right click on them. Yeah. So thanks for coming. Thanks for the chats. Sorry about all the interruptions. My kids keep unplugging my router. And you have a wonderful evening. Yep, thanks, LC Congru. You have a good night too. Bye bye.